One more topic, very important topic for the SAT or EmSAT is about the half-life problems. So without wasting the time, let's see that which kind of the questions can come in the SAT or EmSAT exam and how does the formula look like. So here you can see the formula for the half-life. It is A equals to A naught times half to the power of T over H. Now what is A? A is the final amount. A naught is the initial or the principal amount. Half, of course, there is the split factor after a half-life, like 1 pound becomes half pound or 100 pounds become 50 pound and so on, to the power of T, that is T is the time, whereas H is the half-life time. So for example, that they are asking you that the half-life of for the 20 years you have to find. So keep it in mind that the half-life will also be given in the years. Means the unit of the time and the half-life will be same. Now let's try to solve few questions. So here is the question. Before the half-life, of course, whenever I see the half-life, so the question or the formula which comes in my mind, it is T over H. Now, the half-life of plutonium-239. Now, here don't get confused. This is the name of the element. So don't confuse yourself by this 239. This could be the atomic weight of that element. A byproduct of nuclear power plants is 24,000 years. Now, if it is years, so of course they are talking about some time. Now the next thing is they are asking you how long will it take a sample of plutonium to decay to 10%. Now what is 10% actually? 10% is it the years? No, it cannot be years. Then it is the amount that could be decayed 10% of its original mass. Original mass. It means they are not giving you that what mass is it. So for that reason you assume. So for example, if I assume that my principal amount, okay, is for example, it is 1 pound. Okay, so what could be my final amount? They says that there is a decay of in the final amount, the decay of 10%. So I can say that this is 10% of 1. And what is 1? 1 is the amount which I assume for myself to make my life easier. Now 10%, I also told you in the previous video that whenever the percent is given, it means automatically it is going to be divided by 100. Of means multiply, and since 1, so anything multiplied by 1 gives you the same value. 10 divided by 100, it will give me 0.1. So it means my A will be 0.1, whereas my A naught will be 1, which I assume, half. Now T is the time which is given as 24,000 years. Over, I have to find out how long will it take a sample to decay. So I have to assume a finalize, or I have to find out my H. So I will divide both sides by the 1 to get rid of this one, and anything divided by 1 gives me the same value. Equals to half whole to the power of 24,000 over H. Now, if you remember that whenever we have some base and having some power with the variable, so in order to solve those questions, we take the log on both sides. So taking the log on both sides, on this side, it is very clear that it is ln of 0.1. I told you in my previous video also there is a property of logarithm, that is ln p to the power of b is written, then the power always comes beside or before the logarithm. So it will be b ln of p. Now write this thing accordingly. So comes this power will come before the ln. So I will get ln 0.1 equals to 24,000 divided by h times ln of half. Now divide both sides by ln of half and 24,000. Okay, so I will divide it over here, 24. Okay, so rather than doing this, I think that I should cross multiply because I need the h on the upper side. So I can write, I can just swap their position since it is my EmSAT exam or SAT exam, so I don't need to show them the steps. I'm doing all these steps just for your sake. So h goes up, ln of 0.1 comes down. So I will get 24,000 times ln of half whole divided by ln of 0.1. This could be the value of my h. So you can calculate it by means of the calculator and get the answer. I'm not calculating it over here and wasting your time to make the video long. You can just write it in the calculator and get the answer. Next question. Now, next question is a radioactive substance. Cesium-137. I told you that whenever they give you any elements or isotopes name with the atomic number, you ignore those numbers. It has nothing to do with our any answer. Okay, has a half-life of 30 years. Now, what is this 30 years? Of course, half-life is over here, right? So, this is the 30 years. So, HL will be as 30 years. This means that after 30 years, half of the amount of cesium turns into something else. If the initial amount of cesium was 70 gram, so in my formula A equals to A naught times half whole to the power of T over H, I know that my initial amount is A naught and it is given as 70 grams. So half stay as it is, and over here I found out that this is my 30. Now, which exponential function represents the amount of cesium remaining over T times in years? Okay, so T stay here. Now, A stay here. So you can see if you look at the options, they are representing A means the final amount as a function of T. So that's it. Just check that which of the equation matches yours, and you should know that half means 0.5. So of course option number B is my actual answer. Now at this step I just want to hold and I just want to tell you that one more thing where the students make the mistake. What do? They rather than they do T by 30, they write 30T. Here there is no option, but let's suppose there is an option f of T equals to 70, 0.5 whole to the power of 30T. So in that case, the students, they without thinking anything, they just say that the E option is correct. Now, this option is not correct. The reason is that in the half-life, the time is always be divided by the half-life years. Whereas, whenever we talk about the exponential functions, if you remember, AB to the power of x is the value of our exponential functions. Or if we talk about the compounded rate, then in the compounded rate, it is 1 plus r over n whole to the power of nt is given. Okay, so normally the students they misunderstood and they interpret and they think that this formula, the formula of compounded interest would be applied over here, which is absolutely wrong. So be careful while solving such questions. Now, another questions which came in the SAT exam, the half-life of a certain substance in an aquatic environment is about 150 years. So you can say that you can see that half-life is 150 years. Okay, so it means I have to see T by 150 somewhere. Okay, half-life here, and now what is my initial amount? In grams of the substance, 80 in Which of the following exponential functions best models the amount A of t in grams of the substance that remains t years? So t is stable as it is after 200 grams of the substance is applied. So 200 grams is given as our initial amount. So can you just think that which could be our option? Our option is D. You are absolutely right. Now what students they do, think they think again that option C is correct. Why? The reason is they thought this is the wrong interpretation of the question, or becoming so excited that they think that this could be the compound interest formula. So never ever make such kind of the mistake.